Hi guys, welcome back. Today we're going to talk more about limits, but before we get started in today's lesson, I'd like you to try these review problems on your own. So hit pause and write down your answers wherever you want to these questions, and then we'll go over them. Okay, I bet you did very well on that. Hopefully you're getting the hang of this easy stuff. So the limit as x approaches -3 from the left would be 1. The limit as x approaches -3 from the right would also be 1, which means the limit as x approaches -3 is 1 because the left and the right-hand limit are the same. Part D, the limit as x approaches 2 from the left would be -1. Remember, limit is a height you're approaching. The limit as x approaches 2 from the right would be +1. And therefore, the limit as x approaches 2 does not exist since the left and right-hand limits are not equal. Easy as could be. All right, so today we're going to talk about limits involving infinity. So main idea here, what we're going to do today is look at the graphic approach to these problems so you can just visualize the answer. And then we're going to do these exact same problems again tomorrow, but tomorrow we're going to approach these problems using algebra. Okay? So today is actually a lot easier. I want you to try to remember that the limit is the height the graph approaches. Okay? So for this problem, the x, think of this as your x coordinate, and think of your answer as the y coordinate. So the limit as x approaches positive infinity would be on the x, so that's asking what's happening here. So what is the height of my graph as x approaches infinity? The height appears to be approaching 8. Okay, this says what is the height of my graph approaching as x approaches -infinity. So as my graph goes to the left, the height seems to be approaching 0. Okay, so again, think of this as your x coordinate and this is your y coordinate. Now you may remember, there's the bell. You may remember that this is an asymptote, so the graph doesn't actually reach a height of 8, but it's approaching a height of 8. Okay, so limits involving infinity are really the same as asking, is there an asymptote? Okay, if there's a limit as x approaches infinity, then that means there's an asymptote, a horizontal asymptote. Okay, this one's sort of the same idea. The limit as x approaches positive infinity would be -1. The limit as x approaches negative infinity would be 4. Actually, I lied. I said -1, but we're apparently counting by 2, so this is a -2 right there. All right, next one. Now we're going to add a little bit more to it. Okay, this one, the limit as x approaches positive infinity appears to be 0. And the limit as x approaches negative infinity also appears to be 0. Remember, the limit is the height. All right, now this one, the visual on this is very important. This says, what is the limit as x approaches 3 from the left? Well, here's 3. As x approaches 3 from the left, there's a vertical asymptote at 3. So if my graph approaches a vertical asymptote, it's always going to go forever either to -infinity or positive infinity. So as x approaches 3 from the left, my graph's height goes to -infinity. As x approaches 3 from the right, my graph goes to positive infinity. So try to remember this because we're leading into it tomorrow algebraically. If I ask the limit as you approach a vertical asymptote, it's always going to be infinity or -infinity. Technically, that also means DNE does not exist since it's not a number. Okay, so here's kind of the same one, just another one. I'm going to take note this time that we are counting by 2s, so I don't mess that up again. Okay, the limit as x approaches infinity appears to be 2. The limit as x approaches -infinity also appears to be 2. Okay, at -1 there's a vertical asymptote. Okay, vertical asymptote. Because remember, if you divide by 0, it's either going to be a whole or an asymptote. Well, if you divide by 0 but you can't cancel the factor like we could with a whole, like if there was another x plus 1 up here and it canceled, that would be a whole. If it doesn't cancel, that's a vertical asymptote. So we know we have a vertical asymptote at -1, okay, and you can see that on the graph. So as you approach a vertical asymptote, you're going to go to either infinity or negative infinity. So as x approaches -1 from the left, this graph goes to positive infinity. As x approaches -1 from the right, the graph goes to negative infinity. And they're not always opposite. It is possible for a graph to both go the same direction. Okay, exponential growth. The limit as x approaches infinity also goes up to infinity. The limit as x approaches negative infinity, 0. Easy, right? Okay. This is the natural log graph. You'll come across this pretty often. It's the inverse of exponential growth. So if you go back to that last graph, that was exponential growth. Everybody knows that one. You have that key point 0, 1. Well, the natural log graph has the key point 1, 0. In the exponential growth graph, this guy, there's a horizontal asymptote. Well, in the natural log graph, since they're inverses, it's going to have a vertical asymptote. So it's going to go through this point and go like this instead. And try to remember that one. It'll come up often. Okay, so we're on the natural log graph. Not that you really needed to know that right now, not yet, because we're doing this visually anyway. The limit as x approaches infinity is still infinity. It's the height. It's kind of hard to see on this graph. Maybe I needed to go further, but it is getting higher and higher and higher and higher. So it is going to be infinity. And the limit as x approaches 0 from the right is negative infinity. So since we're just doing these graphically without having to do algebra, this is a pretty easy assignment. If you're in class, you're going to do a matching activity right now. If you're online, then you're going to do it in your homework. So that, believe it or not, is the end of today's lesson. You're going to do a worksheet that just practices that. It'll be real quick and easy. And then this is also some book work just to review everything we've done so far on limits. Hope you're doing well. If you have questions, guys, please, when you have a question on your homework, take a picture of what you've done, because then I can find your mistake usually a little easier. Okay? Good luck, everyone.